Hello, I'm Michael Tressler. I'm a Senior Customer Engineer with Microsoft, and I'll be presenting the second module in our Teams Rooms Foundations training covering network readiness. You may wonder why we're bringing in networking into this training. Why aren't we talking about configuring a Teams Rooms or how to design one right now? The reason is, if the network isn't good, then your Teams Rooms experience won't be good either. We will focus on the cloud-based connectivity, so Microsoft Teams and Skype for Business Online. But keep in mind, many of these principles apply to Skype for Business on premises as well. What are we going to learn in this module? We're going to learn about the investments Microsoft has made to optimize network connectivity for not just Microsoft Teams, but all of Microsoft 365. You'll have a better understanding of how media travels across networks and understand how to optimize your network to best take advantage of Microsoft 365. Microsoft Teams is not an update to Skype for Business. Rather, it's a brand new, born-in-the-cloud software solution. It solves many of the issues that Skype for Business had. Remembering Skype for Business dates back to the mid-2000s. Starting a brand new product from scratch for the cloud solves a lot of legacy issues from Skype for Business. So meeting joins are much quicker and much more reliable. I no longer ask people, can you see my desktop when I share a desktop? I just share my screen, wait 2 seconds, and comfortably assume everybody has it because everyone always does. Meetings have been simplified by using fewer ports and easier to configure the entire environment. Joining meetings is a lot easier. There's one click or a tap to join audio conferences specifically on Teams Rooms devices, but also in your calendars, and when joining a meeting within Teams, a single click and it takes you to the join screen so you can pick your audio and video. There have been improvements in Wi-Fi, mobile, removing echo and howl, and many other features that make the application much more enjoyable to use. You may be surprised to hear that Microsoft is one of the largest networks on the planet. You don't think of Microsoft as a network provider, and ultimately we're not, but we have data centers across the globe. And so we need to get them all connected at super high speed, super low latency networking. And so this slide highlights a lot of the things about the Microsoft network. But on the right-hand side, that column is what's most interesting to us with Teams Rooms, optimized for media. Unlike the general internet or even corporate networks, the Microsoft network knows what kind of media to expect and acts accordingly, prioritizing the important media. So here is how you generally connect to a website on the internet. Call it Facebook or Twitter or MSN.com. You're sitting in your corporate network. The corporate network you have full control of, you have full responsibility for it. You have to pay for WAN connections and security and many of those things. And then you, at some point, route to the internet. And the internet is very limited control. You basically can only choose your ISP and maybe a DNS provider, and after that you're kind of out of control of what you can do. So the internet is a little bit wild, a little bit uncontrolled, but it works really well. Your users will be able to get to MSN.com or Twitter.com or Facebook.com. However, when you go to the Microsoft network, this isn't what's happening. Let's take a look down here as we see what happens here. And note that the internet has shrunk and the Microsoft network picks up the majority of the connection. So yes, you still start on a corporate network. You're still looking to go to Microsoft 365. You're still looking to go to Office.com, and you still have the strengths and weaknesses that corporate networks have. But because the way the Microsoft network is designed, the time you spend on the internet is greatly reduced. And that gives it a lot of great features. It reduces jitter, loss, latency. It reduces latency, which is critical when connecting audio and video. The Microsoft network has no jitter and loss, almost no latency. I mean, there's only so much we can do about physics. And it's been designed to be focused on Microsoft-specific technologies and not the general purpose internet. This should be a familiar picture. It's the same one we saw on the last slide. But we can do a little more than that. What if we can reduce the corporate network and get your traffic onto that zero jitter, zero loss Microsoft network even faster? And the way to do that is to introduce local internet breakouts where it makes sense. There's a lot to discuss and a lot to decide. How many of our locations need local internet breakout? Can we use regional breakout? And it all depends on how big is the region. If it's an entire country, is it a large country or a small country? If it's a state or a province, is it a large state and province or a small state or province? How many people are going to be using that network? Is it going to be overloaded if we send it to a regional area? Or is there plenty of bandwidth? What kind of bandwidth is available at those branch offices? So there are a lot of decisions to be made to decide if every office or every location needs to have local internet breakout. But if you're any kind of a regional, national, or global corporation, you should certainly consider corporate network. You should certainly consider local breakout. Passing your traffic halfway across a country or across a globe just to get to the internet doesn't make sense when dealing with Teams media and dealing with Teams Rooms media. To help with this, Microsoft has things called Azure Front Doors. Now, you usually think of a Microsoft data center as a giant building with a bunch of air conditioning and power and security and all kinds of huge things. These Azure Front Doors are small versions of that. They still need air conditioning and power, and they're definitely secured. But because they're smaller, we can move them closer to where the users are. So we have many, many Azure Front Doors. And you can think of it as that is hosting the location where the applications connect. So in this example, we see the Azure Front Door for Exchange Online, SharePoint Online, and Teams. In Exchange Online, those are client access servers, and Teams, those are transport relays. And those provide low latency, high-speed connectivity for the client so that the client has a snappy, quick response. Certainly there are times that the request needs to go back to the data center. So I live in Florida. I have an Azure Front Door in Atlanta, Georgia. But my Microsoft data center is in the state of Virginia. You don't have to know the US geography to understand that, sure, if I connect to Atlanta, Georgia, my client will be quick, but occasionally we need to go from Atlanta to Virginia. But because we're on the Microsoft network with low latency, those longer distance calls to core backend data happen really quickly. And so the Microsoft network is designed to work in multiple layers and to try to give clients the fastest connectivity that they can get. So here are the things we can do to optimize connectivity. Local internet breakout. Now when we talk local internet breakout, don't forget local DNS resolution. What does this mean? It means that if you have a branch office that has local internet, that branch office has to be able to go out to the internet as well for DNS. If you have your DNS set up so that all DNS requests get forwarded to the corporate headquarter data center in a different country, the Microsoft DNS servers will see the DNS requests come from the corporate headquarter and not the local branch, and assume that the user is at the corporate headquarters, not at the local branch. Thus, it'll return an accurate DNS entry for the corporate headquarters, but not one for the local branch. So the local branch needs local DNS so that the Microsoft DNS servers can realize where they are located and give them the optimal DNS and DNS response, which would be an IP address to an Azure Front Door close to them. We also want to remove as much internet as possible. And by internet, we mean the wild, wild west that is the internet. The internet doesn't support quality of service. You can't necessarily control the routing. You can't control what network traffic is there, bandwidth controls, things like that. So the less time you spend on the internet, the better you are. And the more time you spend on the Microsoft network, the faster your performance will be, the better the audio and video in your Teams Rooms meetings will be. If you want to see where Microsoft is peered, you can go to aka.ms/8075 and see a list of all the locations on the globe that have peering relationships with Microsoft. And we'll get into peering and routing here on this next slide. So here's a view of the internet. On the left in that big circle where it says Teams Client, that's us on our corporate network. That is we, the corporate employee, doing what we do on a daily basis. And at some point, we need to go to office.com. Now, if you have a poor ISP who doesn't really have great relationships or they're very small, they may not be very good at routing your traffic. It takes a long way to get around to the Microsoft network. That's clearly not optimal. As we saw in the previous slides, we want to spend as little time on the internet as we can. So if you have the option, work with your ISP and encourage them to create a peering relationship with Microsoft if they don't have one already. Or encourage them to optimize their path to the Microsoft network by having better peering relationships with other ISPs. In this case, maybe peering with ISP number 2, which then has a relationship with the Microsoft 365 network. Ideally, this is what we'll want. Your ISP peering directly with Microsoft. In this case, the traffic technically hits the internet, but it never leaves one vendor, your one ISP. So that should lead to optimal routing, that should lead to optimal performance, and that should lead to great audio and video for Teams Rooms. Here's an example of a corporation based out of Barcelona, Spain. You'll note that this is the classic traditional networking model where all the branch offices in England and Austria and Italy have WAN connections to Barcelona. So when one member in England wants to share something across office.com, there's a big U-turn that has to happen. It goes down to Barcelona, up to the data center, and then back to all of the peers in that conversation or in this meeting. Well, the Microsoft network has all of these different peering locations. And so look at this. With these locations now have very short and usually in-country connections to the Microsoft network. So their ISPs peer in-country. So you have a much faster response. You're spending a lot less time on a corporate network. You're spending a lot less time on the internet. And there's a lot less of a hairpin of the traffic. It goes to the Microsoft data center and directly to the peers in Austria and Italy, as opposed to having to go down to Barcelona to get to the peers in Austria and Italy. So this is what we're looking for: less latency, a more direct connection, and the majority of the traffic is happening on the Microsoft network. So how does media flow in Microsoft Teams? And this also is very similar to Skype for Business. When two people call each other, so you're calling a coworker to discuss something, and there are only two of you on the call, that will be a direct call or a peer-to-peer call, meaning the media, the voice and video, will travel directly from my workstation to my peer's workstation. That's assuming things like firewalls, proxy servers, NAT, and the like aren't in the way. But if we're in the same office building or potentially even on the same campus, that shouldn't be a problem. So the traffic actually never gets to the internet, at least the media traffic. There's signaling traffic which does go up to the service to control things like putting people on hold and things like that. But the idea is that the media travels directly between two users. Now, as soon as you add a third person in, that becomes a meeting. It can be ad hoc, so the two of us are talking, and I just grab a coworker into the call because we need to ask them a question. As soon as that person joins the call, the meeting converts to a meeting. Actually, the call converts to a meeting, and all of our media is now traveling to a Microsoft data center somewhere where it combines all of our media streams into one and passes it back. In general, Microsoft Teams media will happen on ports 3478 across the board. However, depending on configurations, which we'll get into, it could be UDP ports 3478 to 3481. And then we'll get into some other ports with TCP and HTTP later. But the thing to keep in mind is, in a two-person call, the media tries to go directly between the two people. And in a meeting, all the traffic goes to a Microsoft data center. It puts them all together and sends the media streams back. So, meeting locations. So we bring a third person in. Where is that meeting hosted? How does that meeting work in a global situation? I'm in Florida in the United States. I may be talking with a coworker in Germany, and that coworker in Germany brings someone into the call from Tokyo. Where is that meeting located? In the US? In Germany? Tokyo maybe? Let's look at that. So this is the key line I want to point out here. The meeting is based on the first user who joins the meeting, be that an ad hoc meeting or a scheduled meeting. So if I join the meeting first, or create the call, that meeting will be hosted in the United States. If my peer in Germany joins the meeting first, the meeting will be based out of Europe. And if a peer out of Tokyo joins the meeting first, that meeting will be based out of Asia. So let's see how this works. Here's a map of the United States, and we have some attendees that are all based in the western half of the United States. So the first person to join is in Texas, and others join. So that meeting will be hosted somewhere in the western half of the United States, which provides optimal audio and video, limited traffic across the country, and again with peering, getting onto the Microsoft network as quickly as possible. Now what happens if we have a tenant based out of the United States, and we have some coworkers in Europe who are going to spin up a Teams meeting? Does that traffic have to come to the United States? And the answer is no. Again, it'll go to where the first person that joins the meeting is from. So in this case, the first person, let's say, was in Germany, and then we have attendees out of England and Spain. So the meeting in this case looks like it's hosted in Amsterdam. So even though it's a United States tenant, the meeting is hosted in Europe, which means the audio and video does not have to travel across the Atlantic Ocean. Rather, it stays within Europe. I mentioned transport relays as sort of the server that Microsoft Teams connects to, at least for media. So a transport relay can be thought of as a Rosetta Stone. It translates between various different protocols so that everybody can speak together. Ideally, everybody is speaking UDP over at least port 3478. UDP is great for audio and video because it is so efficient when compared to TCP. However, in situations like in the bottom diagram, where somebody has to use cannot use UDP, they may have to use TCP or HTTP, the transport relay can translate between TCP and HTTP and UDP. So depending on what you're allowed to do on one side of a network versus another dictates what the transport relay is going to receive. The thing to keep in mind is if there are 5 people on the call and 4 people can connect via UDP and the 5th can only connect via TCP, that TCP connection has no direct impact on the other 4 attendees. The other 4 continue to use the most optimal UDP, and the 5th attendee will use TCP. Now that is a slower protocol. It is not as good for real-time audio and video, so that 5th attendee may have poorer audio and video, but they will still be able to join the meeting and not have an impact on how the others connect to the transport relay. How do we find a transport relay? This goes back to the comments made earlier about DNS and having local DNS resolution capabilities. There's something called an Anycast IP address. It is a single IP address assigned to geographically dispersed servers. Now, I thought I knew TCP/IP really well, and then this Anycast thing got invented, and now we're putting IP addresses in multiple places. I thought that broke the rules. But that's why Anycast is great. You connect to an IP address, and it routes you to the closest accurate instance. So when you start up Teams, Teams always looks for one IP address across the globe. However, based on where you are, it will connect to a location close to you. So Anycast is voodoo magic, but it works extremely well. So it is Anycast that will direct you to the closest Microsoft data center or Azure front door. So the client connects to Transport Relay's Anycast IP of 52.113.192.2. So that is the global Anycast IP address. However, through magic, you are then routed to the closest transport relay, and then an available transport relay answers and redirects from the Anycast to an actual individual IP address. So let's say we have 100 transport relay servers across the globe. Not all of them have the same IP address. It's the Anycast that has the same IP address. Those 100 transport relay servers will have 100 different IP addresses. So UDP 3478 is always used for initial communication with the transport relay. And if you look at the bottom here, we can see 3478 is used for discovery, and 3478 is used for audio, video, and sharing. So in all cases, by default, with Microsoft Teams and Teams Rooms, UDP 3478 is used for all media. Now that is controlled by this on-off switch found in the Teams Admin Center. If you leave it off, everything stays on 3478. If you turn this switch on, you will now see that Teams will use 3478 for initial discovery and negotiation, media negotiation and discovery. It will then use 3479 for audio, 3480 for video, and 3481 for sharing. And the reason for this is with QoS, now that we're using 4 ports and 3 specific for media, we can apply different priorities to different media. So audio is almost always chosen to be the highest priority, video the second highest, and desktop sharing the third highest priority. So given a situation where we're out of bandwidth, audio would be given the first chance to make it through the network. So if you're interested in quality of service, this checkbox or this switch in Teams Admin Center enables Teams to use multiple UDP ports. Here's an example of what we talked about earlier, where UDP is blocked for one of the attendees. So they can now use TCP or HTTP to connect to the transport relay. The other attendee or attendees all have UDP, and it's a transport relay that translates between TCP or HTTP and UDP. Now this is also the case if you're in the same building, but I'm in building 1 and I have a firewall that blocks UDP, and you're in building 2 that is behind a firewall that does not block UDP. For us to be able to communicate, we will have to go to a transport relay. We will not be able to have that peer-to-peer communication. As was mentioned earlier, quality of service. Here is the screenshot of where you can find that in the Microsoft Teams Admin Center. If you go down here, look at aka.ms QoS in Teams, and that will give you all of the details on how to set up quality of service within Microsoft Teams. You can control how much bandwidth is used within Microsoft Teams. Note that this is for meetings, and it only applies to the meeting organizer. It is the meeting organizer that defines how much bandwidth will be used in that meeting. So if I'm an attendee in a low bandwidth situation, and I join a meeting hosted by somebody in a high bandwidth situation, in that the meeting attendee has plenty of bandwidth, my bandwidth will not be limited even though I am at a low bandwidth location, because the meeting organizer is the one whose policy gets used for that meeting. We generally don't recommend changing these from the default values. Our codecs dynamically adjust to the available bandwidth, and so they will lower the bandwidth required, or lower the video quality, or lower the audio quality dynamically when there is a low bandwidth environment. So we generally don't recommend using this. However, there are situations where it is necessary. So what are the things to discuss or to review about your network? The number of sites. If you only have one site, you clearly don't need local internet breakout. If you have thousands of sites, you may want regional internet breakout, because the expense of managing and maintaining 1,000 internet sites plus WAN links back to the corporate headquarters may be prohibitive. But you could then have regional sites so that everybody goes to a central location within a state or province and then gets the internet that way. Local or centralized internet, basically what I just talked about. Are you geographically dispersed, or are you all within the same, say, metropolitan area? At that point, centralized internet works fine. Do you need QoS? You may not. QoS is generally only needed when you're low on bandwidth. When you have plenty of bandwidth, you don't need QoS because you never have congestion on your network. Now, you may have congestion on the internet link, and there's little to nothing we can do about that short of buying more bandwidth and or getting on the Microsoft network as quickly as possible. And then other things, how much bandwidth do you have? Do you need to increase bandwidth when implementing Teams and Teams rooms? Are the firewall ports and URLs open and available? Local or centralized DNS? The same answer you use for local or centralized internet will be the same answer for local or centralized DNS. Those two go very much hand in hand. And then VPN and proxy. What are your VPN and proxy rules and decisions that need to be made? User types. Do we have a lot of people sitting in centralized offices, or do you have a lot of employees remote, working from home or working out in the field? Are you all Microsoft 365? Are you all on premises, or more likely a little hybrid, a little bit of both? So how does that tie in? And then how many external users do you have, and how many guest users do you expect to bring into your Teams and into Teams Rooms meetings? To help answer those questions, there's a network planner in Teams Admin Center. If you're not familiar with this, I recommend you take a look at it. It gives you estimates of how much bandwidth is going to be needed at any given location, and helps guide you on making sure you have enough bandwidth for Teams Rooms and Teams in general. Proxy servers and firewalls. Proxy servers should always be bypassed with Teams Rooms devices. There's little to nothing that a proxy server provides in value to Teams Rooms, except for a poor experience, because it just sits there, isn't able to keep up with real-time media, and introduces a poor experience for Teams Rooms meetings. Teams Rooms is designed to inherit proxy settings from the Windows operating system. If you have auto-configured PAC files, that will work. However, if you must define a proxy, you can do this via the admin account in Teams Rooms. It's completely documented on how to do that. It gets a little squirrely as you have to open the registry keys for the Skype user, but it can be done. And no matter what, never do deep packet inspection or break it and inspect on real-time media. There's literally no point, and it will cause performance issues with Teams Rooms. Teams Rooms doesn't need too much more than regular Teams and Skype for Business. Windows Update, by default, the application is distributed via the Microsoft Store, so getting access to Windows Update is important for Teams Rooms. If you're going to use Intune to manage Teams rooms, there are a few more URLs that need access, and then you do want to keep the time synchronized. Many organizations choose to keep Teams rooms in a workgroup and not in Active Directory, so you want to make sure the time is right so that you don't walk into a meeting room and things are off by 20 minutes and the meeting's already started or isn't on the calendar yet because configuration, the times are off on Teams rooms. If you're running Teams rooms in a workgroup configuration, be sure you're able to access a network time source. What are some tools you can use to check your connectivity with Microsoft 365? The best tool is connectivity.office.com. So this is the website down here. You can enter your city or let Windows Location Services find your location. At that point, it'll bring up a drawing, hopefully this one up here. This is me in Florida, and here's that Azure front door in Atlanta I was talking about, and this is the data center in Virginia. That is where I get routed to. I know a little more about this, so I never actually go to this Azure front door in Atlanta because I really joined down here in Miami, and so this ends up being the correct path. And by really joining, I mean my ISP has a peering relationship a little further down here with Microsoft. So I do peer in-state, but then it's actually just as quick to go to Virginia as it is to Atlanta when you're down here. Here's an example of me being connected on a desktop VPN to Frankfurt, Germany. And you can see the diagram, the map, immediately shows the connectivity to here, and you can't see it, but there's a red X on this back pin saying this is not the optimal front door. You should be using one of these front doors. So this tool will point out when there are issues to be found. There's advanced testing. You can download and install a net.net application that runs, as of this recording, 429 different tests, including media tests. And so here we can see when I'm connected without a VPN, I have very good media metrics. So if I were to have Teams rooms here at home, I would have no problems with media. Now, if we run this same test while connected to Frankfurt, Germany, there is a lot of red to see. Here, these red appear not necessarily because the call was not successful, as in the call was able to connect, because we see we have media connectivity, but the metrics were so poor that you will not have a successful call. There will be dropped audio, dropped video. It'll just not be a great experience. We can see we're way beyond the recommendation for how many miles or kilometers I'm away from a Microsoft data center, and then that I'm not using a DNS server that is local to me. In other words, it's not local internet breakout. So I hope you have a better understanding of the Microsoft Network and Microsoft 365. We went into detail how Microsoft 365 is designed and how the whole goal of the Microsoft design is to minimize your time on the internet and maximize your time on the optimized Microsoft network. There's some tools to test it with. If you go to connectivity.office.com, run this on a Teams Rooms server. Sign in as the admin. It's just a web page. Maybe you have to install a version of .NET, worst case, and you can then see on that Teams Rooms how good is connectivity to Microsoft 365. So you now have a better understanding of Microsoft 365 and how to optimize connectivity for Teams Rooms to either Skype for Business Online or Microsoft Teams.